In breath alcohol levels, we're going to talk now about how would we test for breath alcohol levels and understanding some of these issues about breath alcohol versus blood alcohol. Blood alcohol is the one that's the sort of gold standard. So breath testing, normally our breath is leaving the mouth at about 34 degrees Celsius. And at that case, if it's body temperature, at that body temperature, the ratio of alcohol in the blood, which is what we really need to know, to the breath is approximately 2,000 to 1. So in other words, if there's 2,000 milligrams of alcohol in the blood, there'd be 1 milligram of alcohol in the breath. So it's a very small portion get exchanged into the breath. That means that internally, if anytime we test the breath alcohol, we have to multiply that number by 2,100. So remember, if I'm testing you on this, just think in your mind there's about a 2,000 to 1 ratio, and there's much less in the breath than there is in the blood. How do we test that? The original breathalyzer and it was worked on chemical oxidation. Literally, they would take a sample and take the alcohol and do the same kind of chemical oxidation that's happening in the liver, but do it in this machine and detect the products and determine from that how much alcohol was in the system. They're not really used anymore, but what we'll see is that the two types that are used, commonly they all get called breathalyzer, and there's very big differences in the accuracy and precision of these two different types. So one is an infrared spectrometer. We've talked a little bit about infrared spectrometry in the drug unit. We talked about it, how it has this fingerprint, and we can use it to identify. It turns out also we can use it to measure. So there's literally a little spectrometer where it shines infrared light through and measures how much is absorbed. Remember, alcohol, we know exactly what wavelengths it's going to absorb, and so it can measure that. And that can tell us how much is in the blood. Then those are, pretty big physical units. They're not going to be in a squad car. They're going to be at a police station or at at a hospital. And then a fuel cell analyzer. Those are the little things you breathe into that are small and pocket-based, using electrochemistry. So to oxidize. So it uses electricity to oxidize the alcohol, and then measures the electrical current. The thing is, it's not so specific for alcohol. It can sometimes be measuring other things, and there's techniques to make it so that they're pretty sensitive and pretty accurate, but they're not eligible to be admitted into court as evidence because there's some issues with those breathalyzers. But they work great for being out in the field. They're nice, they're small, they're handheld, but they are not currently allowed in court. They're not quite sensitive enough. So this is what the infrared breath testing instrument looks like. So this one is a variation on the breathalyzer that is called the Datamaster DMT, but there's a whole variety of them. But notice it's a fairly big unit. This would lift up, and inside there's some controls, and then you can see this is where it's breathed into, and the machine runs the test. It's sending light through the breath sample and detecting how much is absorbed in the particular wavelength the alcohol absorbs and measuring. So this is what we got. We have this infrared light going through. Would be now filled with the breath from the suspect, and it's filtering out. It's only looking at the absorption for this one wavelength for that alcohol absorbs that, and then it goes into a detector and it reads out blood alcohol content. So there's some conversions in here. Remember, we have to do that times 2,100 to convert it to a blood alcohol content level from a breath alcohol content level, but it's all automated within it. So these fuel cells, this is what the units we tend to see, look like. These various different ones, but you blow into them and it can do a readout. So it's doing a electrochemistry test with using electricity. So if you want to test the breath alcohol properly, it's important to get a good measurement. And to get a good measurement, One, it has to be a very large sample, 1 to 2 liters. So a 2-liter bottle of soda, we think about that. That much breath as you just kind of inhale and exhale, like that's not nearly enough. So it has to be a big breathed out. Deep breath, long, full exhale. Also, if that suspect has recently eaten something, or especially something like mouthwash, which has alcohol in it, that alcohol is not coming from being in the blood. That alcohol is just straight up. So you can have very high levels that are not representative of what's truly in the bloodstream. Belching is an issue. All of those will increase the mouth alcohol and lead to high readings on the breath detector. So because of both of these things, you want to repeat the test a few minutes later. So one test is really not sufficient due to so much variety of things that can happen. So you would take a test. Obviously, you don't want people taking tests immediately back to back. They're going to probably pass out. So a test, a few minutes later, a second test. Also, the testers, the infrared spectrometer, has to be calibrated against some known alcohol content standard very routinely. And if that's not done, the electronics and the various detection units can kind of drift over time. And so that part of being recalibrated against a standard is a very important part of making sure you have accurate readings. And these are both true with the fuel cell analyzers as well as the infrared analyzers. In the field, again, we talk about these field testing. So you could use a breathalyzer, but often, remember, we need to justify an evidential test because of this idea of you can't force somebody to participate, even with the implied consent aspect of the driver's license. There needs to sort of have some level of probable cause. So field sobriety has become an important part of justifying, yes, I can give them an infrared or a fuel cell test. So the one that's particularly accurate and precise for giving us an indication that it's under the effects of alcohol is something called the horizontal gaze nystagmus test. So this nystagmus test is one that we'll spend some time talking about. Then there's also just general motor control of walking and turning and one leg stand. So balance is affected, walking is affected. So just kind of the general observation of, are they walking like a regular person? Are they on a one leg, can they stand on one leg? But as we know, some of us just are kind of klutzy and can't stand on one leg even when we're fully sober. So the horizontal gaze nystagmus is particularly helpful because it is something that is unique to being under the effects of certain drugs, and in particular alcohol. The idea is that the eyes of an individual can't, under the influence of alcohol, can't track smoothly as they move from side to side. They tend to jerk. It's hard to describe. I will show you a picture of it. But the idea is that the longer it takes them to sort of catch up, the smaller the angle from straight ahead at which you start seeing this jerking motion, the higher the level of intoxication. So this is a test that you'll see officers perform. Other drugs can do the same thing, like especially PCP does this as well, but it's not all drugs, so it ends up being a fairly good test for testing for alcohol. So I want you to watch these of how to perform the test, but the general idea would be as you have them follow something from, you kind of usually have a stick or something and you're having them follow from side to side and you're watching, at a certain point you'll start seeing like that the eye kind of jerks a bit, and if it's when they're way over here, probably none or maybe very little amount of alcohol. But if you barely start going over and you start seeing it, suggests they're highly intoxicated.